Hello everyone, I'm Hele and welcome to our background introduction section of our final project. Our project revolves around natural language processing and a very important method called latent semantic analysis. So we expect any students who completed our activity will have the ability to know what NLP is, and understand the basic concepts in NLP, which is natural language processing, and that involves a bag of words, TF-IDF representation, etc., etc. And also, students should have basic idea on the mathematical construct or mechanics, as well as the application of latent semantic analysis, which is LSA. More importantly, they should recognize the importance of SVD, which is another concept that we couldn't be more familiar with throughout this course inside the implementation of LSA. So let's start with some definitions. Natural language processing is the processing and understanding of human language by computers, and it's also one of the oldest and most important AI tasks. The built-in difficulty of NLP is that human language is ambiguous. One single word or a particular phrase can have different meanings under different contexts. Well, to be honest, that's even hard for a human being to distinguish which word has what meaning in a specific context, and not to mention for computers. And so the general process of a natural language processing project will start with pre-processing of raw data. And that includes removing unwanted tags. If you're ripping off tags or web pages, you might want to remove all the HTML tags and also the encoding tags as well. And you will need to determine word boundaries, and which is also what we use in our project, is we use white space as delimiter between each word. And we should also remove stop words, including the, of, a, with, something like that, because they do not convey any specific meaning. They just make the language fluent. And also, usually people will lowercase all their characters in all the text. And finally, if you're capable to do that, you can stemming or limitize the words from different tenses to its original tense. For example, you may change looked and looking to look. And the most important concept in natural language processing, or one of the most important concepts, is bag of words representation. And that is used to represent a piece of text as numbers. So let M denote the size of the vocabulary, and given document D, let C, given W and D, denote the number of occurrences of W in D. So let me explain this for a minute. So C, W, and D is the frequency or the number of occurrences of the word W inside document D. So that's a so if you normalize that with some number, you're going to get a probability or distribution of a word or of different words in a document, and that's what we use to represent the document when we're building a project in NLP. So a more generalized representation for bag of words looks like this, and the ZD is normalization factor that I just mentioned, and in most of the cases, DD will be the number of the length of the documents, or you can say the number of all words. And since if you normalize your bag of words representation with a factor, you get a probability distribution, and that can be used to model the language or text that we obtained. So for example, we have text now, I had some hamburgers for lunch, and then each word inside a sentence is a token, and if I have some duplicate words, say I have two some or two hamburgers in this sentence, they will contribute to only one token, but their probability will increase because they have higher frequency than other words. And now that we have known what a bag of words is, we're going to introduce a representation called TF-IDF. And if you recall that during pre-processing of raw data, one of the key features that we should achieve is that we should remove all stop words. And TF-IDF as a representation have built-in immunity to the stop words. So by definition, TF is term frequency or normalized term frequency, and that is the occurrence of a term inside the document normalized by the length of the document, which is pretty similar to bag of words. And IDF means inverse document frequency, which is calculated by the number of documents containing W, which divides the total number of documents, and then take the natural log of this fraction. So what this term does is that for words that occur in every document, this fraction will become 1, and then their natural log will effectively become 0, so that in the final TF-IDF representation, if you multiply the frequency, the normalized term frequency, with the term's inverse document frequency, those stop words are the words that are most likely to occur in every single document. Then more likely they will more likely to have a 0 weight inside the TF-IDF representation. So instead of using just the naive normalized term frequency as bag of words, we now have a regularization factor called IDF, and now that's the new representation we want for the document. And before we go to LSA, there is another key feature called cosine similarity that we thought will be important to introduce. So the idea is that the similarity between two pieces of text can be measured by the cosine of the angle between two feature vectors. So for example, if you have a representation of a document D1, then you take the inner product of VD1 and another document VD2, you will get this numerator of this equation, and then the denominator is used to normalize your result so that you are treating each document as if they have unit length. So now this fraction becomes the cosine value between those two documents, and by definition, a cosine value close to 1 means those documents lie closely to each other in the vector space, whereas a cosine value close to 0 means they are orthogonal to each other, which implies they have no correlation or so. And finally, we are going to introduce latent semantic analysis, which is a technique for analyzing relationship between a set of documents and a term they contain by producing a set of concepts related to the documents and terms. Well, LSA assumes that words that are close in meaning will occur in similar pieces of a text. A matrix containing word counts per document with the rows represent a unique word and a column represent a paragraph or a document is constructed from a large piece of text. We call it corpora, which is the collection of all text. And SVD is used to reduce the number of rows while preserving the similarity structure among columns. Documents are then compared by taking the cosine of the angle between the two vectors formed by any two columns. Values close to 1, as we have introduced in cosine similarity, will represent very similar paragraph or documents, while values close to 0 represent very dissimilar paragraphs. And what LSA operates on is a occurrence matrix. It uses a term document matrix can describe the occurrence of terms in documents. A typical example of the weighting of the elements of the matrix is TF-IDF, as we mentioned before. And the weight of the element in the matrix is proportional to the number of times the terms appear in each document, where rare terms are weighted up to reflect their reflected importance, while common terms are weighted down to diminish their importance, just as the subwords. Well, as powerful as NLP is, there are several ethical issues related to it. Firstly, it is possible that the training data consists of hate speeches and abusive languages, and without supervising the data, these raw data filled with wrongdoing words could easily teach the machine to behave in a way that hurts people's feelings and severely bias the model in the wrong direction. Secondly, the data collection of NLP could also lead to privacy issues, as one of the major means of collecting data is to record people speaking, and which can serve as an identifier to one's identity. That, as some of you might know, your voice is also unique to. Well, voice is also a biometric identifier as well as fingerprints. So that leads to some potential risks. So that's all for background introduction, and please complete the activity and read the, well, if you're interested, you can read the references we provided, especially the YouTube video listed here. It provides a very simple yet insightful explanation of LSA. Thank you.